Section 4, Video 2. In this section we're going to talk about properties of isosceles trapezoids. So we just talked about the properties of kites, and so this is just another little piece of review from your quadrilateral chart. And so we're just talking about the properties. So we know from the definition that isosceles trapezoid has equal legs, so those non-parallel sides. If I was going to draw kind of a basic isosceles trapezoid, we know that these legs here are going to be congruent. And since we know it's a trapezoid, we also know that there's one pair of parallel sides. And we also know about an isosceles trapezoid that those base angles are equal. So those angles that are kind of running up against on the same base, the same side, are going to be congruent. So we talk about some properties. We know it inherits all the properties of a trapezoid, which aren't very many, but we know that there's that one pair of parallel sides. Like I said earlier, those base angles are equal. And we also know that the diagonals are congruent. So that's to say that if I draw a diagonal this way and this way, that the distance from here to here is the same as the distance from here to here. It's a little sloppy, but I just really want to make it clear that those distances are the same. That's what I mean when the diagonals are congruent. So if we apply those properties to this problem we have here, given isosceles trapezoid ABCD, we know that angle A is 124 degrees. So that's to say that that upper left angle is 124. Find the remaining angles. Well, I know that because it's an isosceles trapezoid that this also has to be 124. And since I know that this side is parallel to this side, I can use same side interior to know that those angles need to add up to 180 degrees. So 180 minus 124 is 56. So I know that this angle down here has to be 56 as well as this angle. Because just real quick, if I was going to sketch, I have extend these parallel lines, and then I have a transversal here, and I have a transversal here, when we think about those same side interiors. So those are the remaining angles. If I was doing this on a quiz or test, I'd want you to go ahead and write, something like angle B equals 124, angle C equals 56, angle D equals 56 as well. Alright, trapezoid mid-segment. Now this should seem familiar. We've talked about triangle mid-segments. It's a very similar thing. So a trapezoid mid-segment is a segment connecting midpoints of legs of trapezoid. So it's, very similar to the triangle mid-segment where we were doing of two sides that would connect the midpoints. But this is kind of like a triangle where you cut the top off. So if we think about we have something called the trapezoid mid-segment theorem, which essentially just gives us two more properties. First, we have that mid-segment that you find is parallel to the bases. So that's to say that red line is parallel to these bases, which makes sense. And then the other property we know is that the length of mid-segment is 1/2 base 1 plus base 2. So it's kind of like the average of the two bases. So for a triangle, we said that bottom kind of base measurement is twice the length of the mid-segment. This is slightly different. This is saying that since we have two bases, it's the exact average of those two lengths, or like what's in the middle, which kind of should make some intuitive sense if you think a little more about it. We have a couple examples to make it a little more clear. So what is the length of the mid-segment for this? Well, we can simply take 1/2 times base 1 plus base 2, which equals 11 plus 17 is 28, and 1/2 of that, or that divided by 2, equals 14. So that's the length of this, since we know it's a mid-segment. And this one looks like it'd be trickier, but you're really just doing the same thing again. So you set it up and you say 1/2 of the two bases, the sum of the two bases, so 10 plus 2x is going to equal the length of the mid-segment, which we're given in this one. It's that 7 here right in the middle. And then we would just solve for x. So I like to go ahead and distribute right away. So 1/2 times 10 is 5. And 1/2 times 2x is just x, because 2 over 2 is 1. And then you just subtract x from, or 5 from both sides to get 2. So x equals 2.